Good morning everyone. Department of Biomedical Engineering. Subject code 24BM 202L. Subject name Bioscience Laboratory. Let's see slide 1. Title Spectroscopy Determination of Absorption Maxima of a given solution. Equipments Optical components, light or energy source, detectors, sample holders, calibration standards, software and data processing, power supply and environmental control. Slide 2. Introduction. Definition of absorption. Maxima. Lambda max. Importance of determining lambda max in analytical chemistry. Let's see slide 3. Objectives. To understand the principle of UV spectroscopy, to determine the lambda max of a given solution, to analyze and interpret the absorption spectrum. Slide 4. Principle of spectroscopy. Interaction of light matter. With Lambert law, A equal to epsilon Cl. A equal to epsilon Cl explain terms. A equal to absorptions, epsilon equal to molar absorptivity, concentration, L for path length, lambda max, wavelength where maximum absorption occurs. Slide 5. Instrumentation. Schematic diagram of a UV spectrophotometer. Key components: light source, monochrometer, sample holder, detector and output. Slide 6. Materials and methodology. Materials: list of reagents and instruments. For example, spectrophotometer. Procedure: prepare the solution. Calibrate the spectrophotometer using a blank solution. Record absorption across a range of wavelengths. Plot the absorption spectrum. Let's see slide 7. Data analysis. Example of an absorption spectrum. Identify lambda max as the peak absorption wavelength. See the model graph and tabulation. Understand the graph. See the tabulation. Wavelength and absorptions. Wavelength for nanometer 350 to 550. For example, 450 nanometer absorption 0.85. Then we see calibration curve for copper sulfate solution. See the graph. Next we see slide 8. Precautions and limitation. Precautions: sample handling. Ensure cuvettes are clean, dry and free from fingerprints or scratches. Avoid air bubbles in the solution as they can interfere with light transmission. Calibration. Always calibrate the spectrophotometer with an appropriate blank solution. For example, solvent used for the sample. Regularly check the instrument's baseline for accuracy. Concentration of the solution. Use an appropriate concentration to avoid saturation or low sensitivity. Dilute the sample if necessary to fall within the linear range of the Beer-Lambert law. Slide 9. Finally, conclusion. Understanding lambda max. Lambda max is the wavelength where a solution absorbs the most light. It is a characteristic property of a substance and can provide insights into its molecular structure. Process overview. UV spectroscopy helps measure absorption across different wavelengths. The absorption spectrum aids in accurately determining lambda max. Let's go to the experiment. This is digital spectrophotometer. Set the spectrophotometer to the desired wavelength 450 nanometer. Set the calibrate, coarse and fine. Then set 0 on concentration. Fill in the cuvette with distilled water, set 0.0, that is blank. Open the lid, cuvette put in the spectrophotometer. Then close the lid. Next, fill in the cuvette S1 solution. Value 0.01. Next, fill the cuvette S2 solution. Open the lid. Cuvette put in the spectrophotometer. Blank 0.00. Set the blank 00. Next, fill in the cuvette with S2 solution. Value is 0.3. Again, set the blank 00. Fill in the cuvette with S3 solution. Value is 1.0. S3 value is 0.9. Again, set the blank 00. Next, fill in the cuvette with S4 solution. Value is 1.1. Again, set the blank 00. Next, fill in the cuvette with S5 solution. Value is 1.1. Next, set the blank 0, 0. Fill the keyword with unknown solution. Final value is 1.1. Calculation makeup of graph. Thanks to all.